In this video, we're going to use integration by parts to evaluate the integral of the natural log of x. But before we work this out, let me just quickly point something out to you. If you start with x to the power of 3, if you differentiate it, it will give you something in the form of x squared. If you start with x squared, if you integrate it, it will give you something in the form of x to the power of 3. So for example, if you integrate something like this, the answer will be something containing x to the power of 3. Now, if you start with x squared, differentiate it, it will give you something in the form of x. So this is in this form here. Now, if you start with something in the form of x, if you differentiate it, it will give you a constant. Now, if you start with a constant, if you differentiate it, it will be 0. And then so it follows this pattern here. It follows. For example, if you have x to the power of 4. If you differentiate it, you will get x to the power of 3. Now this x to the power of 3 here is here. And then the pattern goes like this. But then if you see it breaks down right at here. This one here, if you try and differentiate 0, it doesn't give you 1 over x. So this bit here breaks down. But then apart from this bit here, if you start from here, then it follows the pattern again. Now if you differentiate this, it will give you something in the form of x to the power minus 2. Which is this thing here. Now, if you differentiate x to the power minus 2, it will give you something along the line of x to the power minus 3. And then if you start with x to the power minus 3, if you differentiate this, it will give you something along the line of x to the power minus 4. You see, this pattern here follows perfectly from here downwards, and then here, and then it follows perfectly all the way up here, but then it breaks down at 1 over x. It breaks down right here. You see this, hang on, you see this does not, well if you look at this here, 1 over x, what is it that what is it that will differentiate to 1 over x? Basically, what is the integral of 1 over x? For some reason, it's the natural log of x. So your map here looks like this. Hang on, our map here looks like this. This differentiates to this, so this goes over here, and then this differentiates to this, and then this goes over here. This differentiates to this goes over here. This differentiates to this, but then this doesn't go over here. It doesn't go over here. For some reason, it's actually, the map looks something like this. This thing here will go to here. For some reason, it jumps into here. So if you integrate this, it will give you back to this. So my next question is, what is it that differentiates to this? So what is it that differentiates to this? So the integral of 1 over, or the integral of 1 over x is now the integral of 1 over x is the natural log of x. So this thing here, if you start with it, for some reason our map, to get to 1 over x, for some reason it just jumps into here. You've got this thing out of nowhere jumps into our map. Now the question is, what is it that would differentiate to this? So let's try and work this out now. What is the integral of one? So what is the integral of the natural log of x? So hang on, we are trying to find this out. We are trying to find the integral of natural log of x dx. Okay, but then visualize this as one block multiplying another block, but this block here is 1. So the trick to evaluating the integral of the natural log of x is to visualize it as one block and another block here, so that we can use this thing here. Okay, so we are now going to integrate the natural log of x, but then let u equals the natural log of x, and then so that's this block here, and then let dv let v prime equals 1. Okay, so the trick here is to let this be equal to 1. So when you integrate, so this thing here is this whole thing here. Okay, so if we are letting u to be the natural log of x, so if u equals the natural log of x, then u prime must be 1 over x. Okay, because if you differentiate the natural log of x, it will give you 1 over x. Now if you look at this bit here, we are saying let v prime equals 1. Now if v prime equals 1, then v must be x. So it's really us integrating this. So now to evaluate this, so now to evaluate this, we are just simply going to follow this. So looking at this, u times v. Where's u? U is here, and where's v? V is here. So looking at this here is u times v. U times v is going to be x natural log of x, and then take away the integral of now u prime. Where's u prime? U prime is here, 1 over x times v. Where's v? V is here. So so it will be this, and then dx. That's this dx here. Now this here gets multiplied to the top, giving you 1. So this whole thing here will be 1. Okay. So this whole thing here will become this. So now to integrate this, to integrate this, you can see all we have to do is integrate this, which is kindergarten stuff now. So if you integrate this, then that will then give you simply x here. So to integrate this, it will give you this thing here. Okay. Let's just double check. So let's try and differentiate this. So differentiating this. So let's double check. So now we are going to differentiate this. Now differentiate this. Let's try and zoom into this bit here. So we've got to use the product rule here. So the product rule is differentiate this, leave this the same. So differentiate the x would be 1, and then leave this the same. That's this bit the same, and then plus. Now the second part of the product rule is leave this the same. So that's us leaving it the same, but then differentiate this, which is 1 over x, and then now take away differentiate the x. That would be 1. So now tidy this up. This bit here is 1, and then you take away 1. So overall, yeah. So you see now we've got something that, well, if you integrate this, it will give you this. Basically, is correct. Okay.